So welcome back again in electricity chapter number 3rd and unit number 2. Topic is resistivity and its properties when the temperature is changing. In other words, the effect of temperature on the resistivity. So we had studied so far that the resistivity of any conductor is given by this equation: rho is equal to mass of electron, number density, charge of electron, and this is relaxation time. So what happens when the temperature increases to the resistivity? So now see, you might have studied about that. When temperature increases, the electrons gain more thermal energy. So it means they are speeding up. So they will collide or reach the other ions or other electrons more rapidly. This is resulting what? A rapid number of collisions. So if collisions becoming more frequent than the previous, then what happens? The value of relaxation time decreases. So when temperature increases, this results in decrease in relaxation time because electrons speed up due to thermal energy. And what is the value of thermal energy? Thermal energy is given by 3 by 2 kB and T. That is, and this thermal energy for electron is completely kinetic. Kinetic means electrons have no potential energy, they only have kinetic energy. So this is going to provide us V is directly proportional to under root of temperature. So here temperature increases, the value of their thermal speed increases, and if this happens, the relaxation time will decrease. Now what is relaxation time? The mean or average time between any two collisions. So if electrons are speeding up, frequency is larger, so tau becomes less, and if tau becomes less, then what happens? This rho is inversely proportional to this, as rho is inversely proportional to relaxation time. So if relaxation time is going to decrease, then definitely rho will increase. Now in case of conductors, there will be no change in the mass of electron, there will be no change in charge of electron, and what about number of electrons? So if we increase the temperature by a certain or large quantity, then there is very less effect on the number of electrons free in the conductor. So finally, which is going to dominate this relation, that is relaxation time tau. So if T increases, then relaxation time decreases, and simultaneously the resistivity of the conductors or metals, generally metals, increases. Now this is clear, no doubt. One more very important relation: the resistivity of conductors is given by rho is equals to rho naught 1 plus alpha and rise in temperature, and rho T is what? It's a resistivity of metal at a particular temperature. So I must mention all the symbols. Rho T is resistivity at temperature T. Rho naught is the resistivity at certain reference temperature, wherever you are starting from. What is your start? Generally it is taken as room temperature. So at reference temperature T naught. Okay. So let's remove this. So, and alpha is equal to coefficient of resistivity, and this is positive for metals. Okay, this is positive for metals. So we shall come to this alpha later on. Now let's understand this equation is what. So this is the value of resistivity at certain temperature. When I raise this temperature by delta T amount, obviously that is a positive quantity, as alpha is positive as well. So this both making this quantity positive. Finally, this right side becomes more than itself. That is, rho T is greater. So if delta T is you can say positive, then rho T is more than rho 0. This means as the temperature increases, direct impact on resistivity is that resistivity increases. From this equation as well, resistivity is directly proportional to rise in temperature. Now what alpha equals to? This is clear, no doubt. This is very simple equation. At certain particular temperature resistivity, at reference level of temperature, this is resistivity. This is a certain kind of coefficient. This is positive for metals or conductors, and delta T is the rise in temperature. So what alpha equals to? Now this equation gives you L naught, or in other words I must write del of rho, this if it is small, del of T 1 over rho naught. So this is the value of alpha. So alpha has a unit of what? Per degree Celsius. So its unit is per degree Celsius. So rho is alpha is what? Rise in resistivity per temperature per resistivity. Okay. Or 4 into 10 raised to the power minus 3 per degree Celsius for metals. Okay. So we have done the effect of temperature on resistivity, how this is going to affect this, and the value of alpha, which is a coefficient of resistivity, and this is positive quantity in case of metals. So finally what we get, in case of metals, the resistivity of metals increases when the temperature increases. That's it, nothing more to go, and hopefully this is clear to you.